So in this video, we are looking at sketching polynomials when they're factored into linear factors. Now, what we have here, going straight into the examples, because we have talked about polynomials previously on this channel. So if you need more of an in-depth background, you can have a look at some of those videos. We are going to go through this, just practicing sketching this, and we're going to sort of identify a couple of key features of our graph. Now here we have the function y equals negative x minus 1 squared, x minus 4. And the question's also asking us, after we sketch this, see what is happening at this value x equals 1. Now I've already gone through and done the working out for some key features. Remember, when we sketch graphs, we need the y and x intercepts. So here for the y-intercept, I've set x to equal 0, and I get 4 as my y-intercept. So I'm just going to label that value up here. And to find the x-intercepts, I set y to equal 0. So once I have 0 here on this side, I'm basically just using the null factor law. Now here it's x minus 1 squared, which is like saying negative x minus 1 times x minus 1 times x minus 4. So here you are going to get two of the same solutions, right? Of here x equals to 1. So that's our first solution. And the other one using our null factor law is that x equals to 4. So these are our x-intercepts. I have one at 1, another one at 4. Now what's different about sketching these is we have to basically draw up a table of values to test basically what the sign of our function is for these different key kind of values on our graph. So basically I've written up a table of values where I have some different x values. I've got 0, 1, 2, 3, 4, 5. I'm going to find the y value by substituting into the rule, and I will basically graph this up. Now, I've actually done one extra value. We don't really need this 3 here. We just need 4 and 5. Now, the reason is I just want to basically see what's happening on either side of these zeros. Now, I want to see what the sign of the graph is basically to the left here, so I can start to draw it. We already know there's going to be a y-intercept here, so it's going to pass through here. But I want to see what's the sign of my graph, basically up here, over here, in between basically these ones here, so I can substitute in a value if I wanted to, but I want to see kind of what's happening here and on this side of it. So writing these in, I'm just going to substitute these into the rule. So you can pause the video and have a go at substituting these x values into the rule up here to find the respective y value. Now when x equals to 0, y equals 4, we know that. When x equals to 1, y equals to 0. When x equals to 2, which is a value sort of in between the 1 and the 4, the zeros, I get 2. When x is 4, y is 0. And when x is 5, y is negative 16. Now, I'm just going to write down the bottom what the sign is. So here it's positive, here it's 0, here it's positive, here it's 0, and here it's negative. So that means that to the left of this value here, it's going to be positive. It's going to go down and hit a 0. Then it's going to go back up because when x is 2, y is positive. It's going to go back down to 0. And then everywhere, basically to the right of this, it's going to be negative because where the x value is, the polynomial just continues down because there are no more zeros for it to come back up. So I'm just going to give a rough sketch of this and then we're going to discuss it in a moment. So like I said, it's going to be positive. It's going to hit 0. It's going to get positive again. It hits 0 again. And it continues down. So I get a graph that looks something like this. It's passed through my intercepts here, here, and here. And using this table of values with the signs, I can determine how the function behaves. Now, let's just notice something here, because the question asks us what is happening at x equals 1. Now, here it's an x-intercept, but notice that it doesn't pass through and continue down underneath. It actually touches it, then comes back up. This is something, because of this square here, we call this thing a double root. So it's going to hit at one point, it's going to touch the x-axis, then it's going to come back up. So what I have here, I'm going to write this down, at x equals to 1. the cubic has a 0. It has a 0, but does not cross the x-axis. The x-axis. Instead, the x-axis is a tangent to the curve at this point. So it just touches it once, then it comes back up. So I'm going to write here instead, the x-axis is a tangent to the curve at the point 1, 0. So this is how we can draw this by finding our y-intercept, our x-intercepts, and drawing this sort of table of signs to determine how our function behaves. Now let's look at a trickier polynomial here. We want to sketch y equals to negative x plus 1 squared times x minus 1 times x minus 3 squared. And once again, it's asking us what is happening at x equals negative 1 and x equals 3. Now I've gone ahead and found the y-intercept and x-intercepts already. You can pause the video and just check that this basically marries up with your working out. But subbing in x equals to 0, I get this equation here, getting y equals to 9 once I simplify this. Once again, finding our x-intercepts, I set y to equal 0, and we use our null factor law, okay? So here, for this particular part of our equation, the x value that will make this thing 0 is going to be negative 1. For this one, it's going to be a value of 1, and for this one, it's going to be a value of 3. So these are my zeros here. Now what I do, I'm going to draw up a table. So I've gone basically from negative 2 all the way up to positive 4. Now if I just label these parts in here, now this isn't to scale, but let's just say this is 9 here, positive 9, that's my y-intercept, and I have x-intercepts at negative 1, positive 1, and positive 3. I want to basically see what's happening on either side of these zeros. Now, when I sub in negative 2 into my rule up here, you can pause the video and have a go. I've already got the answers here, so I'm just going to write them in. You're going to get that y equals to 75, okay? So it's going to be positive over here. So the sign, it means, when we say positive, it just means it's going to be above the x-axis here. So the y value is positive. At negative 1, it's 0. So that just means 0 here. It's going to be an intercept. At x equals 0, y is 9, so it's positive here. At x equals 1, it's 0 again. At x equals 2, it's negative 9, so it's negative here. At 3, it's another 0, because that's the intercept. And at 4, it's negative 75, so it's going to be negative. So this thing here maps out how our function kind of behaves and where it is in relation to these intercepts. Is it going to be above the x-axis or below? So we have here that it's going to start really high in the when x is negative 2. It's going to touch our intercept, but then the sign is going to be positive again. So it's going to start up here. It's going to hit my intercept. Then it's going to go up past my y-intercept. Then it goes back down to the other intercept. And when x is positive 2, my y is negative. So it's going to go underneath the curve. So it's going to go underneath the x-axis. Then it comes back up to 0. Let's try that again. But now the sign at 4, so over here, it's going to be negative again. So this once again touches and goes back down. So my function looks something like this. Now, if I just write in all these points, so we have negative 1, we have positive 9, positive 1, positive 3. You can see our table of signs helps us to kind of draw this. We have our significant points here that I label in. I know the curve's going to pass through them. And I know whether the curve, by substituting into this table of values, I know when the y value is going to be positive, 0, or negative. and that gives me enough information to draw a rough sketch of this. Now, once again, the question's asking us what is happening at x equals -1 and x equals 3. It's the same thing as in the previous example. So we can say at x equals -1 and 3, we can say the curve meets the axis, the x-axis, without crossing it. So the exact same thing happens. The x-axis is a tangent to the curve at those two places. So it touches, then stays positive, passes through this intercept, and then touches here and goes down. And as we said in the previous example, this thing is a double root. That's the effect of this power over here. When we have it like this linear factor x minus 1, you can see at the 0 here, it actually crosses the x-axis. When you have this double root, like you see here and here, it just touches. It's a tangent, so it comes back up. It only touches the x-axis once. Same down here, it touches it once, then goes back down. But that brings us to the end of the video. This is how we can sketch our polynomials when they're factored into linear factors. Thank you so much for watching, and I'll see you next time.